Hi guys, Mrs. Grabner here. We're going to talk about the Ed puzzle today for your lesson on similar figures. We're going to be using proportions again today. If you've noticed, this whole week is about applications of proportions. We're going to start up with just kind of a proportion to get you thinking in terms of this. So we have an employee working at an electronics store earned $3,582 for working 3 months during the summer. So what did the employee earn for the first 2 months? So without any other information, we just have to go with what we know. And the first thing that we know is this much money for 3 months. So when we do a proportion setup, we're going to have money, $3,582, and that was earned over 3 months' time. So we have dollars over months, and if you remember anything about proportions, it's that the labels are important and they have to be the same on both sides. So if I look over here then, where do I get the other piece of information? There's one other number in the problem, and it was 2 months. Because it's months, that's definitely going to go on the bottom because of the way my labels are, and we're trying to figure out how much money they actually earned in those first 2 months. So that'll be an X on the top. From here, we're going to cross multiply. So we have 3,582, and we're going to multiply that by 2 because that's multiplying across, and we get 7,164. And on the other side, 3 times x. So then to get x by itself, we're going to divide by 3 on both sides. And when I divide the 7,164 divided by 3, I get x is $2,388 because my label for X was money up here at the start. So they earned this in 2 months. So that's just kind of a quick refresher to get you thinking about proportional thinking here. We're going to use that again today. So if you have the actual notes packet, we're on page 17 today. If you're just taking notes in your notebook, that's fine too. Just make sure that you get that ready. I'll give you a second, pause the video, get that together. All right, for today, similar figures. Similar figures are going to have the same shape, but they are not necessarily the same size. So think about the picture of the different trains that we saw as our warm-up question for today. They're exactly the same, they're similar, they're the same shape, but they're different sizes. When we have similar figures, what we end up having is, I call them a mama and a baby shape. And what happens is their angles, so example, angle B down here and angle E over here, are actually going to be congruent. They're going to be equal to each other. And the other thing that happens, so the corresponding angles are congruent, which also means equal. And the lengths of the sides are actually going to be proportional. So when we say corresponding means they're located in the same spot, but they're just on the 2 different figures here. So this side, AB right here, if you can kind of take a look at this one, corresponds to this side, DE, over on the mama shape over here. We call them corresponding, they're in the same spot. Now, the cool thing that happens is those sides are actually going to be proportional, which allows us to be able to solve for missing sides. Notice we have an X and a Y here. So just going down here, when we have triangles, these triangles are similar. It means that our angles are going to be congruent. So, for example, we have angle A, which is right up here, and that matches up on the mama shape with angle D. So we would say angle A is congruent to angle D. We have down here angle B, like Boyertown, is going to be congruent to angle, it matches up over here to angle E. The last one that we have here is C and F, so angle C is congruent to angle F. That's the other one that we have. When we talk about proportional sides, that's when we talk about sides. AB is proportional to DE. So AB and DE. Proportional sides would be BC across the bottom here and EF. So BC and EF across the bottom. And then this slanty one, we have AC, and that corresponds to DF over here then. So those are actually going to form proportions then. So it says use proportions to find the values of X and Y. So looking at my picture, I'm going to do a little bit of work here. I'm going to circle up this 3. And we said that this side was going to be proportional to this side. So I'm also going to circle up the side length there, which is 15. The 4 goes across the bottom, so I'm going to box that. And the y is in the same spot, so I'll box that one. And then finally, this x, I'm going to put a triangle around him, is in the same spot as the 35. Now, notice that one of our sets, the circled ones, have two numbers in it. So we're going to actually start our proportion that way. So we're going to do a proportion setup. And if you remember up here, the first side was 3 on the baby to 15 on the mama. So we're going to do 3 for the baby, 15 for the mama. And if it helps you over here, we'll put baby over mama. Now, we need to solve for x and y. We can't do that at the same time because notice the x goes with the 35, but the 4 goes with the y. So in the sake of going x's first, let's just do x over 35 because we had baby over mama for the first one. So baby over mama has to be the same way in our next one. So we're going to have x over 35. We're going to go ahead and cross multiply here, and we're going to get 105 equals 15x. We're going to divide by 15 on both sides, and we're going to get x equals 7. So that missing side that we found up here, this x, is actually going to be a 7. Now, we still need to go back and find y. The only problem is, don't use this 7 that you just figured out. Use the ones that were initially there to start that we used in our first one, 3 over 15. So we're going to reuse them, and it was still baby over mama. So let's go to the ones that have y. 4 over y, baby over mama. So 4 over y. And we're going to go ahead and cross multiply here. We're going to get 3y equals 60. Divide by 3, and we're going to get that y equals 20 then. Okay? If you're following along in the notes packet, we're on to the next page then, which is 18. Notice we have these two trapezoids. What I do first is I always go through and I say, okay, here's my 5. This is AD. This corresponds with this side, which is y plus 4. Then I have my 2x is going to correspond with this x plus 12. And I have finally this 24 is going to go with the 48. Notice how I actually had the 24 and the 48 were the only ones that had both pieces there. So I'm going to go ahead and say 24 over 48, and I'm going here to here every single time, top to bottom of my proportion. And if it helps you to label them like that, that's great too. Let's solve for x first. So we're going to do the x's. This is 2x. So this is the top, 2x. And on the bottom, we're going to have x plus 12. So then we got junk in the trunk here, 24, parentheses, x plus 12 equals 2x times 48. 2 times 48 is 96x. Oh, we got x's on both sides. This is an ugly one. So we're going to have 24x plus 288 equals 96x. Move the 24x over because it's smaller. And it also makes sense because that'll get the 288 by itself. And that'll also give us 72x over here. Divide by 72, and we get that x equals then 4. Okay? So starting off, you're going to have 24 over 48. We're solving for y now. And on the other side, we want to fill in the piece that we have with the y's. So we have 5 over y plus 4. I'm going to have you pause the video and solve this one and figure out what you get for y. So going along here, we're going to go ahead and solve, and that's going to give us 240 over there. And then we're going to get 24y plus 96 equals 240. Subtract the 96. 24y equals 144. Divide by 24. Divide by 24, and we get y equals 6 then. What that allows us to do is to go back and actually find the side lengths. So knowing that x was 4, that actually makes the different sides here 2x, 2 times 4, which is going to give us 8. So the side BC is actually going to be 8. FG is x plus 12 if we look at the picture. So 4 plus 12 is going to be 16. And if you look at EH, this was y plus 4. Go ahead and figure out what is this side length going to actually be. So y was 6, 6 plus 4, this side is going to be 10. Last example here is what we call a nested one. So we have this little guy triangle and this big triangle here. What I recommend you do is just a real quick sketch. 3, 4, 5, redraw the little one, big one, y, x, 12.5. So you're going to go ahead, the 3 goes with the y, the 4 goes with the x, the 5 goes with the 12.5. So both of my proportions are going to start off 5 over 12.5. 5 over 12.5 because that's a proportion there, and you need to use the pieces that are already there. I'm going to go ahead and solve for x. If I do little 1 over big 1, I'm going to do little 1 4 over big 1 x. It's going to give me 5x equals 50, divide by 5, x equals 10. Go ahead, set up your proportion for y and solve that one then. So we'll again start off with the 5 over the 12.5 because that's the two pieces that are given. We now want to use the 3 and the y. This was the top, this was the bottom. So this 3 is going to go on the top and the y will then go on the bottom. We're going to cross multiply, so you get 5y equals 37.5. Divide by 5, and we learned that y equals 7.5. And that's the end of your lesson then.